Assalamu alaikum. I am Jahangir Alom, lecturer in physics. I welcome you all in my online class. First of all, thanks to Almighty that He has given me the ability to take this class, and I am still okay. Dear student, I also hope all of you are well by the mercy of Almighty and passing your good moments with your study. Dear student, today we are going to conduct a special class on some very basic items and some short questions from the fourth chapter of physics. There is the chapter of work, energy and power, and I hope this class will help you a lot to do better in your MCQ part. Right, dear student? Mainly we will discuss on the very basic definition, the mathematical expression or formula, dimension of the quantities, unit of the quantities, and some short question for the MCQ part. So dear student, let's start our class. Dear student, first we need to know the mathematical expression to solve mathematical problem or do mathematical sum in this chapter, and the necessary expressions are W is equal to Fs or mgs. Here W is equal to work, F is applied force, S is displacement, or W can be expressed mgs. Here m is equal to mass, g is acceleration due to gravity, and h is the vertical displacement or height. Ek is equal to half mv square. Here Ek is equal to kinetic energy half mv square. M is mass and v is the velocity. Ep is equal to mgh. Here Ep is equal to potential energy, m is mass, g is acceleration due to gravity, and h is the height. V is equal to half k x square. Here k is spring constant and x is the expansion of the spring. So V is the stored energy in a spring. E is equal to mc square. So Einstein's mass energy relation. Power P is equal to W by T or mgh by T, and efficiency obtained energy divided by input energy multiplied by 100%. So these are the expression to solve mathematical problem, right? So dear student, now we are going to see some short questions for the MCQ. Okay, dear student, here are some short questions, and the questions are, you will face this type of question in your MCQ exam. So first they mention the what or work is a, that is here you need to mention work is what type of quantity, right? You know work is a scalar quantity or work is a derived quantity because work depends on force and displacement, right? So work may be a scalar quantity or derived quantity. Then the dimension of energy, you know dimension of energy, energy or work depends on, you know, work or energy depends on force into displacement, right? So dimension of energy, force, for the force dimension of is m l t inverse 2 multiplied by x. So dimension of x or displacement is L. So finally the expression will be m L square t inverse 2. So this is the dimension for the energy or work. If a boy complete a round around a circular path, then the work done by the boy will be. So dear student, suppose a boy is complete a round around this circular path. You know work depends on force and displacement. So if the boy start from this point and after the completion of round the boy will come to the same point. So in that case the displacement of the boy will be 0 because the initial point and final point of the boy will be the same. So displacement will be 0. So work done by the boy, force multiplied by 0 will be 0. So work will be 0. right? Question 4, energy released from the nucleus of uranium-238 is almost. So dear student, you know, in the nuclear bikriya or fusion bikriya, the energy released from the uranium-238 is almost 200 mega electron volt. Okay. In question 5, they said that work done on a projected body is, the options are positive, negative, against the force. That is, when a body is projected upward, you know, the earth is pulling the body towards its center and the body is moving against the applied force by the earth. Since the body is moving against the applied force by the earth, so in case of gravitational force, the work will be negative and against the force. So here the correct option will be 2 and 3, right? In the next question, they said that how many neutron will be released from uranium-235 if it is struck by a neutron. If uranium-235 is struck by a neutron, then after the fusion, 3 neutron will be released from the nucleus of 3 neutron will be released after the fusion of uranium-235, right? So dear student, in question 7, they said that the amount of uranium in nature, you know, in nature the amount of uranium is almost 0.7%. Okay. And finally they said that HP is a unit of, you know, HP is a practical unit of power, right? So HP is a practical unit of power. Okay. Okay, dear student, now say said that answer the question number 9 and 10 on the basis of the STEM, and the STEM is 1 gram of mass is converted to energy, right? So first question is, what will be the equivalent energy? So dear student, in our today's class we have already discussed that from the mass energy relation we can write E is equal to mc square. That is, if a mass is converted to energy, then the equivalent energy from the mass will be E is equal to mc square. Here m is the mass of the body, here mass of the body is 1 gram. So first we need to convert the mass into SI unit, so it will be 0.001 multiplied by c square. You know, the velocity of light which is denoted by c is 3 into 10 to the power 8 square. So after the calculation you will get 9 into 10 to the power 13, 9 into 10 to the power 13 joule. So this is the equivalent energy or produced energy from 1 gram of mass. So what will be the energy in kilowatt hour? Dear student, you know, kilowatt hour is a practical unit of energy or work. So you know, 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joule. 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joule. So if we divide this value by 3.6 into 10 to the power 6, then we will get the energy or amount of energy in kilowatt hour, right? So 9 into 10 to the power 13 divided by 3.6 into 10 to the power 6, and after the calculation you will get 2.5 into 10 to the power 7 kilowatt hour, right? So the amount of energy in kilowatt hour will be 2.5 into 10 to the power 7 kilowatt hour. In next question they said that 1 kilowatt hour is equal to, already we have mentioned in our previous question, 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joule, right? The amount of work done by 10 Newton force if a body is displaced by 2 meter against the force, right? So amount of work, that is when you know amount of work W is equal to F into X. Here both of the quantity force and displacement are vector quantity. Here applied force is 10 Newton, but the body is displaced against the force. So here displacement is minus 2. So the result will be minus 20 joule, right? In question 13 they said that example of work against the force, that is when a body get a displacement or move in the opposite direction of the applied force, then it will be known as against the force or negative work. So here the examples are climbing on a horse, walk along a railway, get down from a tree, traveling by a car. So dear student, among the option we can say that climbing on horse. If you climb on a horse, then you need to move your body or displace your body against the gravitational force. So this is the example of negative work or work against the force. Then they said that a part of mechanical energy, that's when you know mechanical energy can be divided into two parts. One is potential energy and another is kinetic energy. So whatever the option, first we need to find which option is present in the question among the potential energy and kinetic energy, right? Both of potential energy and kinetic energy are present here. Here the options are chemical energy, kinetic energy, electrical energy and magnetic energy. So from the given option we can say that the mechanical energy will be kinetic energy. Which energy exists in a moving body? That is when the energy, that is the ability to do work by a moving body, is called its kinetic energy due to its motion. So if the body is in motion or in a moving body, the energy will be kinetic energy. Okay. Finally they said that kinetic energy depends on. So from the expression already we have discussed, kinetic energy Eg is equal to half mv square. So from the expression derivation we can say that kinetic energy depends on m and velocity of the body, that is mass and velocity of the body. Here the options are mass and velocity, velocity and force, mass and force, momentum and force. So from the given option, the right option is mass and velocity. Right. Yes, and our next question are, in the next question they said that which one is a source of renewable energy, right? That's when you know the sources of energies are divided into two parts. One is renewable source of energy and another is non-renewable source of energy. That is the source of energy which can be used for several times or multiple times are known as renewable source of energy. As for example, flow of water, that is current of water, flow of wind, that is wind energy, water energy. These are the example of renewable source. On the other hand, the source which cannot be used for the second time after the first use, that is the source of petrol, gas, coal. So these are the source of non-renewable energy. Okay. So here the options for the first question is petrol, gas, coal and water. From the given option we can write that, or you can say that the correct answer is water. Water is the source of renewable energy. Then potential energy is stored in a spring. That is when the stored energy, that is the energy gained by a body due to its change of position or due to the change of its shape is known as potential energy. When a spring is stressed or compressed, then a energy is stored in the body. This type of energy is known as potential energy. So energy stored in a spring definitely should be a potential energy. Okay. Conversion of energy in the engine of a car. So dear student, you know, in the car we use fuel to produce heat and which can be converted to mechanical energy, right? So proper conversion of the energy in the engine of a car is chemical to mechanical, right? Here the options are mechanical to chemical, chemical to heat, heat to chemical, and chemical to mechanical. So proper option is chemical to mechanical, right? Finally, they said that kinetic energy of an athlete having mass 60 kg is 1920 joule. What is his velocity, right? You know, the relation between velocity, mass and kinetic energy is Ek is equal to half mv square. So from the expression we can write that V is equal to square root of 2 into Ek divided by m. So using the value of the given expression 2 into 19620 divided by mass is 60 kg. So after the calculation you will get 8 and unit will be meter per second, right? So dear student, these are the very basic thing of this chapter and I hope you will be benefited from our today's class. So you need to practice this type of problem and this type of item from your textbook or test paper, and I hope it will help you a lot. So dear student, if you have any confusion, you can ask your subject teacher or you can ask me. We will try our level best to make it easy. So thank you very much being with me in my class. May Allah bless all of you. Assalamu alaikum.